What's up, guys? It's your girl Chrissy Hahn back here with another epic math vlog. Alright, we're learning about functions right now, okay? So you're about to learn some crazy stuff. It's gonna be epic. Make sure to leave a like on this video, smash that subscribe button, and turn on notifications so you don't miss another epic lesson. Alright, without further ado, here is the math wizard herself, Chrissy Hahn.
Hey guys. All right, this is lesson 120, the last lesson for this week. And we're doing something called functional notation. Remember when we talked about scientific notation? It was just a certain way that mathematicians had developed of writing out scientific exponential numbers. Functional notation is just the same idea. It is a shortcut of how to write that we're dealing with functions. So let's take the function we were working with in the last lesson, y equals 8x plus 2. What we do to write this in functional notation, we would say y of x. That's it. Functional notation, you always have the dependent variable on the outside, independent variable is on the inside. Okay? So this said we would say y of x. So then, if we wanted to, let's say they give us a value for x. If they want to find y for x, y of x for this function, if x equals 1, okay? There's all kinds of things happening in this house right now, guys. If we want to find y of x for this function, if y equals 1, then all that means we're going to plug y in for x and solve. One other thing we do in functional notation is we can write it like this. Y of x equals 8x plus 2. They're telling us they want us to put in 1. See, we would write y of 1 equals, 8 times 1 plus 2. So we've just put in 1 for both of the x's. But this one, we don't solve for this one. This is just part of the functional notation. So now we will do y of 1 equals 8 plus 2. So y of 1 equals 10. That's where we stop. We don't solve by dividing for 1 to get rid of it. This is just part of functional notation so that when we look at an answer, let's say that you see, just going to make up one real quick. Let's say you have this function and they tell you they want you to do y of x, and they tell you down here that y, this isn't going to be right because I'm just pulling numbers, y of 4 equals 37. If all you see is this and this, you know they plugged in 4. Okay? I don't think that works out mathematically, but it's just an example. All right? So that's called functional notation. And you can use any letters for this, okay? Let's say they've given you 2 functions, okay? On the next page, if you look at page 603, they've given you y equals 17x, and they've given you y equals negative 6x. So sometimes we're working with 2 different functions. So let's see. It says we can't represent both functions as y of x because we wouldn't be able to tell them apart. So what we do is use different letters for the dependent variables. So we could change this one. Let's just change, let's see which one they change here. F and G. So this one, we would do F equals 17x and G equals negative 6x. So now when they give us an x value, we can plug each one in and find out, let's see, they give us the value of x equals 2. So for this one, that would be 34 if x equals 2. And this one would be negative 12. Do you see if we had left them both at y, they both would have said y equals, but they would have had different values. So sometimes it's okay to change the dependent variable. I didn't change the independent variable, just the dependent variable, so you can keep track of which function you're working with. All right, that's it for today's lesson. Let's look at some examples. We're not going to solve, just look over letter A. They want you to find the area of that figure. Well, if you look at that area, you have a rectangle on top of a parallelogram. So you can find the area of the rectangle, find the area of the parallelogram, and then add them together. Okay? The other thing you could do, I don't know if you'll be able to see this or not. Let me see if I can draw it.
You can guess.
You don't want to guess. All right, so what they do, they have this shape, and then they come out like this. And they tell you that these sides are parallel, and these sides are parallel. They tell you that this is 4 feet, and this is 4 feet. They tell you that those are all right angles. And they tell you that this is 8 feet. So what you could do here, guys, because you know that this is 8 feet, and this is 8 feet, which means this is 8 feet, you can assume that this shape fills up this space, which would mean you have 8 times 8, and that would give you 64. That would make up for that amount of space there. Or you can do the area of this rectangle plus the area of this parallelogram. Either of those ways. Turn the page. All right, letter B. You have a function. We have to decide the domain and the range. Let's look at this. Let's look at the domain first. That's the independent variable, letter x. X is in the denominator. We know the denominator cannot equal 0. What would we put in for x to make it equal 0? A negative 5. So we know the domain cannot be negative 5. Therefore, the domain is all real numbers except negative 5. So our answer has to be either A or B. So now let's look at y, the range. Remember, a fraction, the only way a fraction can equal 0 is if there's a 0 in the numerator. Well, we know that's not going to happen because there's already a negative 2 in the numerator. So the range is all real numbers except 0. So letter B is the answer. All right, letter C, it says a function, y equals 4x minus 3. Find y of 7. All that means, guys, is you're going to plug in 7 for x and solve for y. So now look at letter D. It says if y equals 60 over x is represented by f of x, find f of negative 20. You're just going to put in negative 20 for x, so you will get negative 3 as the answer. 60 divided by negative 20 is negative 3. All right, number 1, functional notation is a short way of writing functions. That's true. Number 2, functional notation makes it easy to see what number you've put in for the independent variable. And again, that is true.
No way.
It's true. All right, guys, email me if you have any questions.
Wait, what about the epic outro music?
All right, Samin wants to give you outro music.
Hit the brakes. Yeah! That's all I got.